The Giant Tortoise's Tale, Islands Within Islands. I am writing this on a boat in the Galapagos archipelago, whose most famous inhabitants are the eponymous giant tortoises, and whose most famous visitor is that giant of the mind, Charles Darwin. In his account of the voyage of HMS Beagle, written long before the central idea of the origin of species focused itself in his brain, Darwin wrote of the Galapagos Islands, "Most of the organic productions are aboriginal creations found nowhere else. There is even a difference between the inhabitants of the different islands, yet all show a marked relationship with those of South America, though separated from that continent by an open space of ocean between 500 and 600 miles in width. The archipelago is a little world within itself. Considering the small size of the islands, we feel the more astonished at the number of their aboriginal beings and at their confined range. We seem to be brought somewhat near to that great fact, that mystery of mysteries, the first appearance of new beings on this earth." True to his pre-Darwinian education, the young Darwin was using aboriginal creation for what we would now call endemic species, evolved on the islands and found nowhere else. Nevertheless, Darwin already had more than a faint inkling of that great truth with which, in his mighty maturity, he was to enlighten the world. Writing of the small birds now known as Darwin's finches, he said, "Seeing this gradation and diversity of structure in one small, intimately related group of birds, one might really fancy that from an original paucity of birds in this archipelago, one species had been taken and modified for different ends." He could as well have said the same of the giant tortoises, for he himself was told by the Vice-Governor Mr. Lawson that the tortoises differed from the different islands, and that he himself could with certainty tell from which island any one was brought. I did not for some time pay sufficient attention to this statement, and I had already partially mingled together the collections from 2 of the islands. I never dreamed that islands about 50 or 60 miles apart, and most of them in sight of each other, formed of precisely the same rocks, placed under a quite similar climate, rising to a nearly equal height, would have been differently tenanted. And he said the same thing about the iguanas, both marine and land, and the plants. With the benefit of hindsight, Darwinian hindsight, we post-Darwinians can piece together what happened. In every one of these cases, and this is typical of the origin of species everywhere, it is islands that constitute the vital, though accidental, ingredient. Without the isolation provided by islands, sexual intermingling of gene pools nips species divergence in the bud. Any aspiring new species would be continually flooded by genes from the old species. Islands are natural workshops of evolution. A barrier to sexual intermingling is what you need to allow that initial divergence of gene pools which constitutes the origin of species, Darwin's mystery of mysteries. But islands don't have to be land surrounded by water. To a highland-breeding giant tortoise, each of the 5 volcanoes along the length of the big island of Isabella, Albemarle to Darwin, who used the traditional English names, is an island of green habitability, surrounded by inhospitable lava desert. Most of the Galapagos Islands are a single volcano, so the 2 kinds of island coincide. But the big island, Isabella, is a necklace of 5 volcanoes, spaced from each other at approximately the same distance as the single volcano on the neighbouring island of Fernandina, which, from one point of view, might as well be a 6th volcano on Isabella. To a tortoise, Isabella is an archipelago within an archipelago. Both levels of isolation have played a role in the evolution of the giant tortoises. All the Galapagos giant tortoises are related to a particular mainland species of land tortoise, which still survives and is smaller than any of them. At some point during the few million years that the islands have existed, one or a few of these mainland tortoises inadvertently fell in the sea and floated across. How could it have survived the long and doubtless arduous crossing? Well, the early whalers took thousands of giant tortoises from the Galapagos Islands to their ships for food. To keep the meat fresh, the tortoises were not killed until needed. But they were not fed or watered while waiting to be butchered. They were simply turned on their backs so they couldn't walk away. I tell the story not in order to horrify, although I have to say that it horrifies me, but to make a point. tortoises can survive for weeks without food or water, easily long enough to float in the Humboldt Current from South America to the Galapagos Islands. And tortoises do float. Having reached the archipelago, the tortoises did what many animals do when they arrive on an island. They evolved to become larger, the long-noticed phenomenon of island gigantism. If the tortoise story had followed the finch pattern, they would have evolved a different species on each of the islands. Then, if there were subsequent accidental driftings from island to island, they would have been unable to interbreed, that's the definition of a separate species, and would have been free to evolve a different way of life from their colleagues of different species on the new island, and also from their colleagues of the same species on other islands. You could say that the different species' incompatible mating habits and preferences now constitute a kind of genetic substitute for the geographic isolation of separate islands. Though they overlap geographically, they are isolated on separate islands of mating exclusivity, so they can diverge yet further. Most of the Galapagos Islands have the large, the medium, and the small ground finch, which specialize in different diets. These three species surely originally diverged on different islands, and have now come together where they coexist as different species on the same islands, never interbreeding, and each specializing in a different kind of seed diet. The tortoises did something similar, evolving distinctive shell shapes on the different islands. The races of tortoises on the larger islands tend to have high domes. Those on smaller islands have saddle-shaped shells with a high-lipped aperture for the head at the front. The reason for this seems to be that the large islands tend to have enough water to grow grass, and the tortoises there are grazers. On the smaller islands there is often not enough water to grow grass, and the tortoises have to become browsers on cactuses. The high-lipped saddle shell allows the neck to reach up to the cactuses. The cactuses, for their part, grow higher and higher in an evolutionary arms race against the browsing tortoises. The tortoise story adds to the finch model the further complication we've already noted. For them, volcanoes are islands within islands. They provide high, cool, damp, green oases surrounded by dry lava fields at low altitude which, for a giant tortoise, constitute hostile desert. Most of the islands have but a single volcano, and each has its own single species or subspecies of giant tortoise. Some have none at all. The big island of Isabella has 5 major volcanoes, and each of them has its own species or subspecies of tortoise. Truly, Isabella is an archipelago within an archipelago. And the principle of islands as powerhouses of divergent evolution has never been more elegantly demonstrated than here in the islands of Darwin's blessed youth.